can be calculated by using f of t and multiplying it with an e power minus st dt and taking its integral from minus infinity to infinity. So this is a general perception that if we want to take the inverse Laplace of that same thing, so what we should do is that we should use the limits of s now. Here we used the limits of t, so we will use the limits of s now, put all the values of s. So let's say we are having a signal and it is something like this on the time domain. So while calculating the Laplace transform, we started with t equal to 0 and up to t equal to infinity. We added all the components, and this addition was termed as this integration. So we added all the components and found some constant value with a function that depends upon frequency. So we converted it like this. Now we are having a function with respect to frequency now. So what we will do, we will put the value of frequency in it, but since time was from 0 to infinity, that does not guarantee that the frequency will also be from 0 to infinity. Frequency can be minus infinity. Why? Because even a sine wave, when converted, it gives us a e power minus s as well as e power plus s divided by 2j, which is not debatable here. So we are having two limits for every signal in terms of frequency. So that's why the inverse Laplace transform has a component 1 over 2 pi j to overcome this frequency f is equal to omega divided by 2 pi. Since we are using here s, so this s is omega, and this Laplace was initially calculated for frequency f. So that's why the radian frequency, whenever it is used, we should be dividing it by 1 over 2 pi. And this j is also with the same reason, that since s is equal to j omega, so that's why for leaving this omega constant, we should be dividing this by j. So this division has come to here. Okay, so this was some basic introduction to this Laplace transform. Here we are having the limits of s. This is the decay constants or the enhancement constants. So here we will have some values of it. Most probably in equations we will not use this mixture, the complex value, but you should know that we can put constants inside it. Okay, and this is the same function, converted function already, and we are multiplying a plus e power st with it. So Laplace transform e power minus st, and inverse Laplace transform e power plus st. In Laplace transform, there is an integral from 0 to infinity with respect to time. In inverse Laplace transform, minus infinity to infinity with respect to s, and we are using a function f of t here. We are using function f of s here, and here this thing is calculated because this is time to frequency change, but here we will use 1 over 2 pi j because this is time to frequency to time change, but we are using j omega, not f. So this is pretty much the summary of this Laplace transform, inverse Laplace transform. So in this table we are having some Laplace transform pairs. If we see that in a constant multiplier with a simple function f of t, we are having a constant multiplier with f of s as well. So that was the reason that in the previous slide, when we wanted to calculate the I of t, it was c dv by dt, which was again calculated as c s and v of s. So this s was calculated with respect to this, and this c was a constant there. This is capacitance, but this was a constant here. So A is constant here, A is constant here. No change in the value of constant. If we are having a plus here, we will get a plus in here as well. A of t, since it is multiplying with time, so multiplier with time is a division in frequency. So frequency domain, it will be a dividing thing here as well as here. Time shifting, if we shift something in time, its frequency will not change, which is obvious that frequency depends upon the speeding up or reducing the vibration, not the delay or advancement of the signal. So there would be a just exponential multiplier with the f of s, while f of s is having no change in its s thing. The frequency shifting is a multiplier of exponent with time. This will be introduced inside this thing. So frequency shift will definitely change the s value by that shift, which is a here. In differentiation, any nth value of differential would have a subtractions of its residue of n minus 1, n minus 2, n minus 3. So we had, let's say, a second order differential d square by dt f of t. So there would be two subtractions, d by dt of f of t and t equal to 0, and then another of f of f of 0 here. So we are having two subtraction here. You can find it by this thing, that first we had an s and power 1 and then s power 0 f of t. S power 1 f of t minus s power 0 f of t minus s square. So s square is f of s. इसमें वैल्यू नहीं पुट करेंगे, इसमें t इक्वल टू 0 पुट करेंगे, इसमें भी t इक्वल टू 0 पुट करेंगे. सो दिस इज प्रीटी मच इट कि अगर हमने कोई डिफरेंशिएशन करनी है तो जिस वैल्यू पे हम है उसको हम डायरेक्ट लैप्लास ट्रांसफॉर्म वैल्यू लिख लेंगे, और उससे जो कम वैल्यूज है तो 2 है तो 1 और 0 वालों में हम t इक्वल टू 0 की वैल्यू पुट. ये हम बाद में डिस्कस कर लेते हैं, लेकिन यहाँ पे आप लोगों के लिए थोड़ा सा आइडिया हम जहाँ पे क्लियर हो जाए तो ज़रा ज़्यादा चलो. अच्छा, मल्टीप्लाइंग बाय अ कांस्टेंट टाइम here, this will result in 1 over s of that same thing. ये हम इससे पहले प्रूव कर चुके हैं कि let's say we are having f of t equal to 1, f of t is 1, so उससे हमारे पास क्या बनेगा, 1 over s बनेगा. So u of t is giving us 1 over s. So if we are having u of t multiplied by t, so इससे पहले हम ये कर चुके हैं ना कि we had a 0 to infinity t dt and e power minus st. इससे क्या आ रहा था हमारे पास s square. So why वो ये आ रहा था, because we had introduced a t with a constant value. So t u of t is same as t because the integration of this is depicting this u of t. So इससे t मल्टीप्लाई करने से हमारे पास यहाँ पे एक दूसरा s इसके साथ आ जाएगा तो 1 over s square बन जाएगा. This same phenomena will occur if we multiply n value. So t power n we would have 1 over s power n plus 1 here. So ये थोड़ा सा यहाँ पे मुश्किल लिखा है, इसको अगर आप समझ रहे हैं तो ठीक है, वरना just know it like this कि जब भी हमारे पास t के वैल्यूज बढ़ेंगे तो नीचे उसका पावर बढ़ेगा और ऊपर उसी का n माइनस 1 फैक्टोरियल आएगा. ये हम बाद में डिस्कस करते हैं, बट यहाँ पे मैं एक जनरल सा लिख लेता हूँ कि t क्यूब का क्या होगा. t क्यूब का होगा 3 फैक्टोरियल डिवाइडेड बाय s पावर 4. t स्क्वायर का क्या होगा 2 फैक्टोरियल डिवाइडेड बाय s पावर 3. t का क्या होगा 1 फैक्टोरियल डिवाइड बाय s स्क्वायर, और कुछ भी ना हो तो 1 का क्या होगा 1 over s. So this is the scenario which these equations are explaining but not clear. डिवीजन बाय टी, जब भी हमारे पास कोई डिवीजन टी पे आता है तो फ्रीक्वेंसी डोमेन में हम उसको एज फ्रीक्वेंसी शिफ्ट लेते हैं. सो दैट थिंग इज कवर्ड इन द एग्जांपल. सो यहाँ पे इसको जरा छोड़ें बिकॉज दिस थिंग इज नॉट इन आवर कोर्स एज वेल, बट एग्जांपल में अगर कहीं पे आए तो हम फिर सॉल्व कर लेंगे. एंड सिमिलरली इंटीग्रल, इन इंटीग्रल वी वुड हैव f of s and 1 over s. In d by dt we have only s. In integral we have 1 over s. So ये हम pretty much describe कर चुके हैं इससे पहले. So let's solve a simple circuit using Laplace transform and inverse Laplace transform. So here we are having a circuit in which we are using u of t. So u of t means that t less than 0 we are having no voltage. So no voltage means no current as well. So writing its we want to find I of t. So writing its voltage equation. So V of s is this voltage is the current in this thing and current in this thing multiplied by the impedances. तो यहाँ पे हम इसका अपना जो differential equation है वो लिख लेते हैं कि L di by dt is V of L. So writing that thing R into I L di by dt and then converting it using Laplace transform. So Laplace transform say Vs of s, V source Laplace transform R I and L di by dt. So L is constant that is here, and after that we are using L di by dt. So d by dt has a Laplace transform of s into I of s minus I of 0. So this one function is in s domain, but this one function is in time domain. Remember this thing. So put time equal to 0. तो 0 या उससे पहले हमारे पास क्या कंडीशन थे कि u of t था, तो u of t में कोई एनर्जी हम दे ही नहीं रहे थे, इस वजह से I of t equal to 0 would be 0, कुछ भी नहीं होगा इससे पहले. So I would be 0 and hence this thing. And now V of s है हमारे पास for final condition. तो V of s is here u of t. u of t का constant का Laplace transform क्या आता है? d e power minus st dt. इसका Laplace transform हमेशा 1 over s आता है, तो constant की बजाय हमने 1 over s लिख लिया. अगर यहाँ पे 12 वोल्ट होता तो हम यहाँ पे 12 by s लिखते. Similarly R I L S I dt. Now what we need is that we should separate this is. So is हमने separate किया से हमारे पास equation आया 1 over L s into R by L plus s. So this is a partial fraction type question जिसमें हमारे पास एक s है और एक s के साथ कोई value add है. So we have separated it into k by s and k by s plus R by L. After that we find the value of these two variables. इसके लेफ्ट साइड को भी हमने थोड़ा सा सिंप्लीफाई किया है जिसकी वजह से ये इस तरह बने. तो अगर हम इस इक्वेशन में कुछ वैल्यूज पुट करें कि पहले हम उसमें s equal to 0 पुट करें. So we had that equation k1 divided by s plus k2 divided by s l plus r, और उसका आउटपुट क्या रहा था s r plus ls. तो अगर हम इसमें s equal to 0 पुट करें तो for that we multiply this thing with s, this with s and this with s. So ये क्या बना 1 over r plus ls is equal to k1 plus k2 into s divided by anything. इसमें अगर हम 0 पुट करें s को तो ये क्या बना 1 over r और ये 0 बन गया equal to k1. So k1 turns out to be 1 over r. Similarly k2 की वैल्यू के लिए हम s equal to क्या पुट करेंगे अब minus r by l पुट करेंगे because r plus ls equal to 0. So ls is minus r and s is equal to minus r by l. So इसे हमारे पास k2 की जो वैल्यू आती है वो क्या आती है -1 over r वो आती है. So putting -1 over r and +1 over r in this equation without these s of course we got 1 over r s plus 1 minus 1 over r SL plus R. सो हमारे पास ये इक्वेशंस आ गए. नाउ अगर हम इस इक्वेशन को देखें तो दिस इज 1 over s r. इसका मतलब है कि अगर हम इसका इनवर्स लेप्लास ट्रांसफॉर्म ले लें, मैं ज़रा ये जगह साफ करता हूँ और यहाँ पे हम इसका इनवर्स लेप्लास ट्रांसफॉर्म ज़रा कैलकुलेट करते हैं. एंड इट विल बी जस्ट from the knowledge that we have from the Laplace transform. So it is a direct step, and you people will use this direct step because Laplace transform is about these things that you should be using some easy steps to convert your equation. So the first thing is that if we have a 1, its Laplace transform will be 1 over s. So now we are having 1 over s and an r with it. So its inverse Laplace transform would be 1 over r. So the first Laplace transform is 1 over r for k1 divided by sr minus k2 divided by r l s plus r. So in the second, let's separate this s from this l. So we will divide this thing by L. So इससे हमारे पास and multiplied by L, so ऊपर चला जाएगा. So we are having something like this कि अगर हम इससे L कॉमन ले लें तो यही L हमारे पास यहाँ पे नीचे आ जाएगा. So this is a bit simpler कि हम इससे L कॉमन ले लें. So we are having this thing. इससे अगर हम ये L कॉमन ले लें तो यहाँ से चला जाएगा, यहाँ पे आ जाएगा. ये वाला हटा देते हैं क्योंकि यही वाला ऊपर चला, ऊपर ही, और ये वाला यहाँ पे क्या है, यहाँ पे ये L आ गया. So we are having s plus r by L multiply by L. So this is the thing that we did, and इसके साथ एक क्या आ रहा है, r भी है, माइनस r भी. So if we check this equation, this is similar to that case कि जब हमारे पास 1 और s plus 1 होता है तो उस ये कहाँ से आ रहा होता है, e पावर माइनस t से आ रहा होता है, e पावर माइनस 1t से आता है. तो यहाँ पे अगर r by l है तो यहाँ पे माइनस r by lt से यही चीज आएगी. So we can write it here as plus 1 over r and e power minus r by lt, because these are the convertible equations. K 1 over s has a Laplace inverse Laplace of 1 and 1 has a Laplace transform of 1 over s. Similarly, e power minus at has a Laplace transform of 1 over s plus a. So 1 over s plus a would have a Laplace inverse transform of minus ad. So we are having s minus r by l. इसका Laplace transform क्या होगा, inverse Laplace minus 1 over r by l t. So वो हमने यहाँ पे replace किया, and now we can take this 1 over r common. So 1 over r 1 और यहाँ पे minus था, sorry, minus e power minus r by l into t. So this thing is similar to this thing. अगर हम ये इक्वेशन डिफरेंशियल तरीके से सॉल्व करते, सो वी वुड बी फाइंडिंग अ पर्टिकुलर सॉल्यूशन एंड देन complementary solution or signal based solution for it. So this is it for the simple circuit using Laplace transform. In this particular circuit we are calculating the I of t for t greater than 0. So अगर हम इस सर्किट में देखें I of t greater than 0 पे हमारे पास ये स्विच ओपन हो रहा है, so we are only left with this circuit. So due to that, our equation would be that v s of s has I of s into r plus the voltage in the inductor. So voltage in the inductor is let's say Laplace of L di by dt, and then voltage across the capacitor, which is